Okay, hi guys. So today is our last day for physics in the conservation unit today. So this is like day 17 in the unit. And hopefully you got your hand in done and you sent that off to me, or you're working on it right now and you'll get it in soon. So what we're going to do today is we're going to look at the outline for the quiz. Okay, and I'm probably going to send that out to your supervisors fairly soon here. Okay, let's open the Blackboard, but let's start off by popping open the quiz here and showing the formulas that will be on there and what they look like. So this is our Physics Conservation Laws Unit 2 exam, and I'm just going to show you the top of it here because that's where all the formulas are. And then we'll go through what the questions are that you will see. Okay, so let's take a look at the formula. So this is all the formulas that you would need to work on this unit. So there's momentum. P equals mv. Okay, that's momentum. Kinetic energy, EK, mv squared over 2. Impulse, okay. Oops, let's get that out of our way. Okay, impulse equals ft, force times change in time, impulse. Gravitational potential energy, mgh, where g is 9.81 meters per second squared, or 9.8. Okay, work energy theorem, impulse momentum theorem, pardon me. Change in momentum equals impulse. Okay. Elastic energy, kx squared over 2. Work, Fd. Okay. Keep in mind that it has to be Fx. Remember, you can have that angle. So sometimes you have to take part of the work with an angle. Okay. Work energy theorem. Work equals a change in energy. Okay. Friction. Whoops, there's the first question. Whoops. Force of friction there. Okay. In case we need it. And then the power formula. It's either work over time or energy over time. Okay, and those are the formulas that you're going to need for this quiz. So let's go through what are the questions, what type of questions will you see on this quiz, and do a little outline and some practice. Okay, so the first thing that you have is you have a 3 single-step energy question. Okay, for 3 marks. So let's do that up here. Let's get our title. Whoops, that's not what we want. Make that a little bit smaller. And let's do our outline today. Okay, so the first thing is this day 17 or whatever it is. This is our quiz outline. Okay, so the first thing that you want to know is that the first question, the formulas are given on the front of the exam. You saw them there. Okay, and you saw them there and what they mean. Okay, so, and then first question 1, is using single-step basic energy equations. To calculate a missing value. And they're all single-step. Okay, and in there, that's going to be 3 points, okay? And it's going to be one of each type. So you're going to have one kinetic, energy, okay, one elastic energy, or elastic potential energy, and one gravitational potential energy. Okay, and they're 1 mark each. They're not that hard. So as an example of that, okay, a spring is compressed let's say 4.8 centimeters, and stores 205 joules of energy, of potential energy. What is the value of its spring constant? So you could pause and try that one if you want, and I'm going to work it out here right away. Okay, so this is an elastic energy one. So okay, elastic energy, that's kx squared over 2. We have to be careful that this is in meters. So x is equal to 4.8 centimeters, which if we change it into a meter, we have to divide by 100. So it's 0.0048 meters, which is the one we have to use. Okay, so then we've got 205 equals k times 0.0048 meters squared over 2. So we got to take our calculator out. 0.0. Oops, I put an extra 0 in there. What am I doing? It's only 1 0. If you divide by 100, I divided by 1,000. Let's fix that. Okay, so if you divide this by 100, you go 2 decimals, not 3. Okay, so this is decimal 0.48 meters. 0.48 meters, so we'll fix that. Just about did a millimeter, we just about did. There. All right, so there we go. So let's go 0.048 squared divided by 2. Okay, so we've got 205 joules equals K times 0.001152. Divide both sides by that decimal number to get our K value in newtons per meter. Okay, and we end up getting two significant figures, about 180,000 newtons per meter. Pretty strong spring constant in that case. Okay, so that's an example of doing those. Now you have 3 of those on the quiz. Okay, let's go on to number 2. Okay, in number 2, I have 2 explain questions, 2 marks each. Okay. Okay, so question 2 is 2 explain short answer questions. Worth 4 marks each. Okay, so for example, I might say, what are the conditions for work to be done on an object? Okay, for work to be done, you have to have a force. You have to have the force going in the same direction as the object moving, and the object has to move. Okay. I might have what is the conservation of energy? What is an energy transformation? What is all those kinds of things that deal with energy, work, power, any of those type things. Okay. Give an example of doing work with of an object having some force put on it with no work being done. Okay, so you'd have to think of an example like that. Those kinds of questions. Okay, so that's number 2. Number 3 is a conservation without friction question. So question number 3. conservation of energy. Question. Without friction. In there. Okay. And there's a couple of different kinds. You get a falling object. Okay, that's the first type. And the second type here is a compressed object or an elastic object. So, and then a compressed object released. Okay, these are both fairly simple conservation ones. They're 2 marks each, so that's a total of 4 points, 2 for each of them. Okay, so if we do an example like that, okay. Example. A spring with a, let's say a spring is compressed. .06 meters with a spring constant of 78 newtons per meter. If the spring holds a 0.22 kilogram mass, what velocity would the mass leave the spring with when it is released? Okay, ignore friction. No friction. Okay, so you can pause it and give that one a try on your own if you like, and then I'll work it out here in a minute. Okay, so if you've unpaused it, so what we're doing here is we've got a situation where we have this elastic energy converting into kinetic energy. Okay, with no friction involved, so there's no worries there. So the elastic energy formula equals the kinetic energy formula. Okay. Now we can work it out here from here, or we can plug numbers, or whatever way you want to do it. Doesn't really matter. Okay, I'm going to cancel out the 2's, and I'm going to solve for velocity. So kx squared equals mv squared, and I'm going to divide by m. Kx squared divided by m equals v squared. Then I'm going to take the square root. Kx squared over m. Okay, and you don't have to do it that way. You can easily plug the numbers in and then work it out. You might have done that already. That's okay. So if I plug in the numbers, I get 78 newtons per meter for K, 0.06 meters squared, and then I've got the mass of 0.22 kilograms, all taking the square root of that at the end. So take our calculators out to crunch that up. Okay, so 0.06 squared, that has to happen first because it's order of operations, times 78, divided by 0.22, take the square root. Okay, so if we do that, we end up getting 1.12 or 1.13. So if we go to two significant, I should have put an extra one there for a significant figure. I'm going to do two significant figures here. It's 1.12 or 1.1 meters per second. Okay, so there's a couple of those. Okay, conservation of energy questions without any friction involved in them. Okay, let's check our times, see where we are here. Okay, we're about 15 minutes. We should be able to get through the whole quiz outline here today. Okay, number 4, question 4 is a work question. Okay, so question 4 deals with work and the work energy theorem. Okay. So let's do an example like that. So question 4, work and question. Work and work energy. Sure. And that one's going to be worth 4. There's 2 parts to it. Okay. Let's do an example. Push on a mass with 112 newtons of force, moving the object, moving the mass. Let's say that it's 2.8 kilograms. And moving the mass forward 8.86 meters. How fast is the mass moving? Okay, so you can try that one. Pause. Try it. So work energy. Okay, so if you unpause it, you're basically using the work energy theorem. Change in energy equals work done. Okay, the change in energy is going to be kinetic. So that's mv squared over 2. It's going to equal the work done, which is force times distance. Now the distance has no angle to it, so that we don't have to worry about finding fx here, but you may have to on the test or another question. So we plug our numbers. 2.8 kilograms times v squared, which we're trying to find, over 2 equals 112 newtons times 8.86 meters. Okay, so if I multiply those two on this side, I get 992.32 joules. Okay, and on this side I have to divide to get 1.4 v squared. So then I divide 992.32 divided by 1.4. I get 708.8. Okay, and then I want to take the square root of that to get the velocity. So 26.6 or 27 meters per second if we go to two significant figures. Okay, so there's work energy theorem like that. Okay, there's a few more questions to go through here. We got 5, 6, and 7, and 8, and 9. Ooh, this is a long one. Okay, so let's keep going. Okay, so 5 is a conservation of momentum question. Worth 3. There we go. Okay, so number 5, conservation of momentum. 3 points. Okay, so an example of this. A cue ball at 250 grams, moving 7.4 meters per second right, strikes the 8 ball that is stationary let's say 180 grams. After the collision, the cue ball stops. Find the velocity of the 8 ball. So you can pause and give this one a try if you want. This might take you 2 days to go through all of these if you're pausing and trying them on your own, but I'm going to try to get them all in one video here. That's okay if it takes you a couple days to go through the review. That's not a problem. Okay, so in this case, we've got a before and after case for momentum. So we've got a cue ball that's moving 7.4 and has a mass of 250 grams. It's a 8 ball that has a mass of 180 grams. Then after the collision, the cue ball stops and the 8 ball moves. We don't know what that's going to be. Okay, so we got to take the total momentum here and equal it to the total momentum here. So if we got to take the momentum, which is the mass of the cue ball times the velocity of the cue ball plus the mass of the 8 ball times the velocity of the 8 ball, and that's going to equal the mass of the cue ball times the velocity prime of the cue ball plus mass of the 8 ball times the velocity prime of the 8 ball. Okay, so that's our conservation of momentum. Okay, so if I plug in our numbers, we've got right being positive, left being negative. So 250 grams times 7.4 meters a second. Okay, this is going to be 0 equals, of course, the cue ball is going to be 0. And then the 8 ball is going to be 180 grams times VB prime, or sorry, V8 prime. Okay, so all we have to do is multiply the left side here. Get 1,850 gram meters per second equaling 180 grams V8 prime. Divide by 180 to get 10.27 or 10.3 equals our velocity. Okay, since we look like we have two significant figures, probably round it off to 10 meters per second. Okay, and that's question number 5. Okay, 6 is another momentum question. It is an explosion lab type question. Okay, so when we did the, okay, so number 6. Okay, you'll be given 2 carts that are going to be exploded. Okay, so that's like the spring cart. You have to calculate the momentum of each cart. Okay, and then you'll have to do, you have to know and then you have to see if they follow the law of momentum or the conservation of momentum, and analyze to see if momentum is conserved. Okay, I'm not going to do an example of that one, because we just did a conservation of momentum one, and you can look back in our notes on that, and that's worth 3. Oops. Okay, question number 7. Okay, we're going to get into, what is it here? All right, so we have a conservation of momentum ramp question with friction. Okay. Conservation of energy, pardon me. Question with friction. Okay, so it'll either be a ramp question or falling, or you're sliding down a ramp or going up a ramp, or a hill question, or falling air resistance question. Okay, as long as it has friction. That's worth 4. We want. There we go. So it's 4 points. Okay, and in this case, we're going to do the most common one I put on there usually is a ramp question. Okay, so let's say it's something like this. Let's do an example. Say you're here, like that. Let's say that you have this mass up here that is 2.6 kilograms. Let's say that this is 0.85 meters, and that this slide path is 5.82 meters, and that the coefficient of friction is 0.20. Okay, and we want to find the velocity at the bottom. Okay, so you can pause and try that one if you want, and I'll be working it out here. Okay, so what we've got if you're on pause now is we have some gravitational potential energy. losing some friction, work done by friction, equaling some kinetic energy at the bottom. So that's essentially what we're going to do. So the first thing we have to do is find the force of friction. So force of friction equals mu mg. So 0.20 times 2.6 times 9.8. Okay, so if we multiply all those together, we get our force of friction. 0.2 times 9.8 times 2.6. 5.096. Not going to round anything till the end. Okay, so now I got to do my equations. So this is mgh minus fd equaling mv squared over 2. Okay, so mgh is 2.6 kilograms times 9.8 times 0.85 minus this number, 5.096 times this distance, 5.82 equals 2.6 v squared over 2. Anyway, I'm going to crunch these numbers. So I'm going to do the work first, and I get 29.659. This one here is 2.6 times 9.8 times 0.85. So, this one is going to be 21.6. So we can see already that it's going to be a negative, so that it's not going to slide down here. The friction's too great for this to slide down. Okay, so let's just round this one to 29.7 here. Okay, so if we do that, we get negative 8.1 joules equals 1.3 v squared. Okay, now if this was positive, you'd divide and figure out what v is, but because it's negative, which could happen, negative energy means there's too much friction. So the object, so v equals 0 meters per second in that case. That was kind of a tricky one. I think the one on the exam will probably move, but maybe not. Maybe it will. Maybe it won't. You have to be careful. Okay, so that was number 7. That was worth 4. Okay, if this is positive, you just continue until you solve for v. Okay, number 8 is a calculation of power. Okay, a couple of calculations of power, like doing a chin up or doing a hop up like we just did last day. So let me do that on the next page. So number 8 is worth calculating power for 5 marks. There's 2 of them. There we go. Okay, so calculating the power, that's 5 marks. There's 2 parts to it. An example of that is if I lift a 22 kilogram box at 0.56 meters off the ground in 2.2 seconds, calculate my power. Okay, so for example, in this case, we have to figure out what our energy is raising this box up. So power, if we know power, I guess you can pause and try it on your own first. Okay, so we had a power being change in energy over time. Our energy is mgh over time. So that's 22 kilograms times 0.56 meters times 9.8 for the gravitational constant over 2.2. So that would be how we calculate power. So I end up getting 54.88 or 55 watts. Okay, then there's a couple of those. And the last one, number 9, is calculating the cost of electric power. Calculating the cost of electricity. So let's say that's worth 2. Okay, so for example, it would look something like this. An oven produces let's say 1,750 watts from its elements. The cost of running the oven for 6 hours. The price is 14.5 cents per kilowatt hour. So you can try that one. And that's our last quiz question. So for this one, we would have to do cost of electricity. So we have to change this into kilowatts. So this would be 1.75 kilowatts. Okay, and then energy equals power times time. So in this case, it's 1.75 kilowatts times 6 hours to give us our kilowatt hours. Okay, so 1.75 times 6, that's 10.5 kilowatt hours. Okay, and then I do the price times kilowatts. And I get $1.52. Okay, so hopefully that will help you, and you can be ready for your quiz, which I will be sending out fairly soon here, or if I haven't sent it out already. Okay, good luck with that. And that's where we'll stop our video. Like I said, it might have took you 2 days to go through that maybe because it's a 40-minute video. That's fine.